Hello, good evening and welcome to distance learning video number 1, which is about ray diagrams. Now, in this video, we're going to look at the use of ray diagrams as a way of predicting the position and the nature of the image formed by a converging lens. This follows on from the lessons we did last week, so I'm going to recap what we did in the last lesson and then move on to other cases. So we're going to look at the rules for setting up a ray diagram, and in particular the special rays that we can draw to locate the position of the image. Then we're going to apply that to particular cases where we place the object at different positions in front of the lens and then work out where the image is going to be. Now, you can draw the diagrams as we go along here on bits of squared paper. Okay, you'll need for this a ruler, a sharpened pencil, and possibly a rubber. Okay, so you'll remember this handout from Friday. If you place a bright object in front of a convex lens, a converging lens, then rays of light are going to leave that object moving in all directions. So some will be going up, some will be going forward, some will be going sideways, some will be going down. Only a small amount of the light that's leaving the object actually makes it to the lens. And therefore contributes to the image that's formed on the other side. Now, we're using the idea of the ray diagram to predict where the image that's formed due to an object placed in front of a converging lens will be. Now, we've done this already experimentally, so we had an actual bright object placed in front of an actual lens, and then we looked for a real image by moving a screen up and down behind the lens. And we have a table to show where the image turns up in those cases. Now, in this theory lesson, we're going to use ray diagrams to predict where that image actually is. The ray diagram is quite stylized, really. So this line here is the principal axis of the lens. This line here represents the lens itself. We know it's a converging lens because it's got these little arrows pointing outwards at the top, which represent the pointy bits of the convex lens shape. For the purposes of the diagram, we say that all the refraction takes place at this line. This is because the lens is a thin lens, and therefore we can theorize that it just acts as a single line for simplicity. The object is represented by just an arrow sitting on the principal axis like this, and then the light that's passing through the lens is represented by these ray paths. Now, many rays leave the object. Only some of those pass through the lens. And the ones that we're interested in are the special rays, where we know where they're going to go. There are 3 of these, but to find the image we really only need 2 of them. Now, I'm calling them the magic rays. So magic ray number 1 leaves the top of the object and goes parallel to the principal axis. Now we know that the action of a converging lens is to bring such a ray and converge it, refract it through the principal focus, and then carries on the other side. The second magic ray number 2, also starts from the head of the object and goes towards the center of the lens. And for reasons that we discussed in the last lesson, such a ray passes through undeviated. It doesn't refract at all, it just goes straight through. Now, both those 2 rays come from the same point on the object. So after refraction, where they meet on the other side, that must be the corresponding point on the image. So we can draw in the head of the object as the arrowhead here. The foot of the object is on the principal axis, so we can deduce that the foot of the image will also be on the principal axis above the head of the image. And then we can deduce that all the other points on the image lie in between, so we can simply draw in the image like that. The third magic ray is kind of the reverse of the first. It's a ray that comes from the head of the object, passes through the principal focus, and then is refracted parallel to the principal axis. So you should be able to see that that's the reverse of what the first ray is doing. But we don't really need to use that ray very often. So for most purposes, we can forget about it. Okay, now the rest of the process for drawing the ray diagram is written here on the rest of the handout, so you can refer to that when you're drawing your diagrams. We're going to draw the first ray diagram on a piece of graph paper. So here we go. First of all, we draw the principal axis, like so, down the middle. Then we're going to draw the lens axis, like this. And we're representing the lens as a single line with arrowheads at the top and the bottom. Now, just to link to what we did in practical, we could draw in, let's do it here, 1, 2, 3, 1, 2, 3, a lens shape, like so. Now, that just is to remind us that what we're dealing with here is a converging lens. Okay, now we're going to use a scale on the principal axis, and the scale is going to be that 1 centimeter on the diagram represents 5 centimeters in reality. Now, if we make the focal length of the lens 15 centimeters, that means that 15 centimeters in reality will be 3 centimeters on the diagram. And that's the focal length. I hope you can read that okay. So if we find the center of the lens here and we count out, that's 1 centimeter, that's 5 centimeters in reality, 2 is 10, 3 is 15. So that's 15 centimeters, and that is the principal focus. Now, there will be a principal focus on the other side, also at 5, 10, 15 centimeters. We'll also put in the point 2f, which is twice the focal length from the center. So if the focal length is 15, 2f is 30, and therefore 5, 10, 15, 20, 25, 30, principal focus, or 2f lies there. And there's going to be a 2f on the other side, 5, 10, 15, 20, 25, 30. So that will be there. Okay, so now we have our lens set up. I'll just put the object in here. We're going to put our object at an object distance of 40 centimeters from the lens. So 5, 10, 15, 20, 25, 30, 35, 40 is here. And we're going to draw the object like so. We don't need to use the same scale on the vertical axis. So if we make the object 2 centimeters tall to scale, we can just call that 2 centimeters. Now, we've got the lens, we know its focal length, and we've placed the object in front of it. Now we can use the magic rays to figure out where the image is going to lie. But we'll do that in the next video.